Assalamu alaikum dear students. Today our topic is characteristic wave parameters. So first we'll define what are characteristic wave parameters. It is defined as the wave parameters are the quantities which defines a set of measurable factors which characterize a wave. So basically these are the parameters which we can use to determine some qualities of wave. So the first one is wavelength. The wavelength is the distance between two consecutive crests or trough. So basically you studied earlier what exactly are crest or trough. Here we can see this is the crest and this is the trough. The distance between two consecutive crests or two consecutive trough. Like this, we can draw wavelength here. So we can see this is the wavelength, or this could be the wavelength, or this could be the wavelength, or this one, or this one. No matter which one we take, it would always be the same. Okay? So we can take just any distance or just any set of two consecutive crest or trough, and we will call this as the wavelength. The wavelength is determined or denoted by lambda. Okay, this is the symbol of lambda and is pronounced as lambda. Okay, so this was all about wavelength. Now we will study about amplitude. The amplitude is the maximum displacement of the particles of the medium from their original positions when a wave passes through the medium. So what exactly are the amplitude we will see here? Consider this wave. Here, what is the maximum distance a particle can travel during wave motion? Let's say here is the rest position of the particle. When the wave passes through it or the energy travels through it, what is the maximum distance this particle can be at? This. This is the maximum distance the particle can travel in either direction. Let's suppose this is the upward direction, then this particle can travel downward at this direction, but these direction would be the same. Okay? So the maximum distance would be d, which is the distance, or this one. Okay, this applies to the whole wave. Now coming to the velocity. The velocity of the wave is the distance traveled by it in a unit time. You are already familiar with the mechanical velocity, the velocity of any object. But what exactly is the wave velocity? We'll get to know here. Let's see this wave. First, see the black one. Okay, the black one covers about 1.5 meters distance in 1 second. We will take time as 1 second as a unit time. Here it will cover about 1.5 meters distance in 1 second. But in other wave, we take this one in red. This red wave will travel about 3 meters of distance in 1 second. So which one has the most velocity? Which one has the highest velocity? Of course, the red one. Red one has the highest velocity because it covers the most distance in unit time. But the black one has less velocity because it travels less distance in unit time. Okay, so this was velocity of the wave. Now coming to the relationship between velocity, frequency and wavelength. This is all mathematical derivations. As we know that velocity equals to distance traveled over the time taken. We've already studied it in the last topic, in the last point we've learned. Okay, velocity is the distance traveled divided by the time. What exactly is the distance traveled by the wave? The distance traveled by the wave is denoted by lambda, the difference between crest and or trough. Okay, so this is the maximum distance a wave would cover divided by, we denote time by t here. Okay, so v becomes lambda by t, or we can explicitly write it as lambda multiplied by 1 over t. Why did we do that? We do that because this term is the number of waves passing through some distance in 1 second. This term is called the frequency and is given by f. We denote the frequency by f equals to 1 over t. This 1 over t term is denoted by f. So we call this equation as equation number 2 and this one as equation number 1. Using now equation 2 in 1, we will get velocity equals to lambda into frequency. Okay, we have placed frequency in place of 1 over t. So frequency is just the inverse of time period, or we can simply write it as f lambda. These are the 4 parameters which are very necessary to understand or to measure the characteristics of any wave. Okay, moving to our next topic. It's the properties of waves. How waves act in different conditions. Okay, the 3 properties are, first we will study the reflection of wave. Suppose we have a table and we place an obstacle here and lamp here. So what will happen when the light comes from here and strike this obstacle? Where would it go? Would it pass just through this obstacle? No, it wouldn't pass. It would reflect from a certain angle like this. It would come from here and it would just reflect from, it would come here, it will reflect, the ray would come here and it would reflect at a certain angle. This is called the reflection of light, the bending of light through a certain angle in the same medium. Now we see the diagram. It is the diagram of the reflection of light. The light rays comes, strike the obstacle and reflect back through an angle. Remember that the angle through which it strikes the obstacle is equal to angle by which it gets reflected back. So this theta will be equal to this theta. This angle would be equal to this angle. Okay, now coming to the refraction of light. What exactly is the refraction of light? For this, we consider a ripple tank. And this is the tank filled with water